All scientific theories have at least 5 characteristics in common. These all have to be present in order for something to be considered a science. The first is that the theory must be falsifiable. This means that the theory must be able to be demonstrated to be wrong. Scientists do this by constructing what is called a null hypothesis. The null hypothesis is the opposite of the experimental hypothesis. So, for example, I invent a new drug for cancer. Let's call it drug X. My experimental hypothesis might be something like drug X cures cancer. That would mean that my null hypothesis would be something like drug X does not cure cancer. In order for the theory to be falsifiable, the null hypothesis must be constructed in such a way that it's possible to prove it to be incorrect. Carl Sagan illustrated the principle of falsifiability in his book called The Demon-Haunted World. He used the story of the dragon in his garage. So suppose I tell you a fire-breathing dragon lives in my garage. So surely you'd want to check it out to see for yourself. There have been innumerable stories of dragons over the centuries, but nobody has really provided any evidence. So what an opportunity. Show me, you say. So I lead you to my garage. You look inside, you see a ladder, some empty paint cans, an old tricycle, but no dragon. Where's the dragon, you ask? Oh, she's right here, I reply, waving vaguely. I neglected to mention that she's an invisible dragon. So you propose spreading flour all over the floor of the garage to capture the dragon's footprints. Good idea, I say, but this dragon floats in the air. Then you say you'll use an infrared sensor to detect the invisible fire. Good idea, I say, but the invisible fire is also heatless. Okay, you'll spray paint the dragon and make her visible. Good idea, I say, but she's an incorporeal dragon, and paint won't stick. And so on and so on. I counter every physical test you'd propose with a special explanation of why it won't work. So now what's the difference between an invisible, incorporeal, floating dragon who spits heatless fire and no dragon at all? If there's no way to disprove my contention, no conceivable experiment that would count against it, what does it mean to say that my dragon exists? Your inability to invalidate my hypothesis is not at all the same thing as proving it true. Claims that cannot be tested, assertions immune to disproof, are truthfully worthless, whatever value they may have in inspiring us or in exciting our sense of wonder. What I'm asking you to do comes down to believing, in the absence of evidence, on my say-so. The only thing you've really learned from my insistence that there's a dragon in my garage is that something funny is going on inside of my head. You'd wonder if no physical tests apply, what convinced me? The possibility that it was a dream or a hallucination would certainly enter your mind. But then why am I taking it so seriously? Maybe I need help. At the least, maybe I'm seriously underestimating human fallibility. Imagine that, despite none of the tests being successful, you wish to be scrupulously open-minded. So you don't outright reject the notion that there's a fire-breathing dragon in my garage, you merely put it on hold. Present evidence is strongly against it, but if a new body of data emerges, you're prepared to examine it and see if it convinces you. Surely it's unfair of me to be offended at not being believed, or to criticize you for being stodgy and unimaginative, merely because you've rendered the Scottish verdict of not proved. Imagine things had gone otherwise. The dragon is invisible, all right, but the footprints are being made in the flour as you watch. Your infrared detector reads off the scale. The spray paint reveals a jagged crest bobbing in the air before you. No matter how skeptical you might have been about the existence of dragons, to say nothing about invisible ones, you must now acknowledge that there's something there, and that in a preliminary way it's consistent with an invisible, fire-breathing dragon. Now for another scenario. Suppose it's not just me. Suppose that several people of your acquaintance, including people who you're pretty sure don't know each other, all tell you that they have dragons in their garages. But in every case, the evidence is maddeningly elusive. All of us admit we're disturbed at being gripped by such an odd conviction, so ill supported by physical evidence. None of us is a lunatic. We speculate about what it would mean if invisible dragons were really hiding out in garages all over the world, with us humans just now catching on. I'd rather it not be true, I tell you, but maybe all those ancient European and Chinese myths about dragons weren't myths at all. Gratifyingly, some dragon-sized footprints in the flower are now reported, but they're never made when a skeptic is looking. An alternative explanation always presents itself. On close examination, it seems clear that the footprints could have been faked. Another dragon enthusiast shows up with a burnt finger and attributes it to a rare physical manifestation of the dragon's fiery breath. But again, other possibilities exist. We understand that there are other ways to burn fingers besides the breath of an invisible dragon. Such evidence, no matter how important the dragon advocates consider it, is far from compelling. Once again, the only sensible approach is to tentatively reject the dragon hypothesis, to be open to future physical data, and to wonder what cause might be that so many apparently sane and sober people share the same strange delusion. This is how Sagan illustrated the scientific principle of falsifiability. For a theory to be falsifiable, there has to be a way to prove it wrong. If you're ever debating with a conspiracy theorist or another individual who lacks critical thinking skills, the best way to end the argument is to ask them what evidence would be good enough to convince them that their theory is incorrect. If they can't answer, then their theory isn't based on reason and evidence, but on the need to believe. The second characteristic of all scientific theories is that the theory must be based on observable evidence. This simply means that there must be something there to observe. Subjective misinterpretations of events and facts vary from person to person based on their own ideologies, wants, and needs, but observable data should remain the same no matter who's doing the observing. Note also that observable evidence doesn't necessarily mean something you can see with your eyes. We can't see radio waves, for example, but we know they exist because we have built electronic equipment that can detect it for us. The third characteristic is that the evidence must be quantifiable in some way. This means that there has to be some way to collect the data on the phenomena being observed, and there should be some way to quantify the observations in meaningful terms. In other words, for the theory to be scientific, there has to be something there to measure. The fourth characteristic is that the data collected can be used to make predictions. This means that in a scientific theory, observations are made so that we can gather data that can be used to extrapolate results. Conclusions can be drawn about what might happen next, given similar conditions. Gregor Mendel, for example, founded the science of genetics by gathering data on pea plants and using the data to make predictions on the characteristics of future offspring of the pea plants. These accurate predictions led to the discovery of the science of genetics. And the fifth and final characteristic of a scientific theory is that the results should be repeatable. This simply means that the same experiment done in the same way should yield the same results. This means that scientists all over the world, regardless of their beliefs or ideologies, should be able to study an experiment and its data, to repeat the experiment, and to get the same results. The next time you find yourself in a discussion or a debate on scientific issues, go over this list and see if the topic being discussed has all 5 of these characteristics. If it doesn't, then it's not a scientific issue.